Good night. I will be doing May 2024, the chemistry paper 2. Okay, so we have section A. It says answer all questions. Do not spend more than 30 minutes on question 1. Sodium thiosulfate solution reacts with dilute hydrochloric acid to produce sodium chloride solution, sulfur dioxide gas, solid sulfur, and water. To investigate the effect of temperature on the rate of reaction, Paul performed different experiments using sodium thiosulfate and dilute hydrochloric acid. For each experiment, the same volume and concentration of sodium thiosulfate and dilute hydrochloric acid reacted, but at different temperatures. The temperature was measured at the start of each experiment, and the thermometer readings for experiments 3 through 7 as shown in figure 1. Define the term rate of reaction. The rate of reaction refers to the speed at which the products are formed from the reactants in a chemical reaction. Write a balanced chemical equation for the reaction between sodium thiosulfate and dilute hydrochloric acid. So we would have gotten that from the next page, from the first page. They told us exactly what type of products would come off. They said that sodium chloride, sulfur dioxide, sulfur, and water will come off from reacting sodium thiosulfate with hydrochloric acid. And so all you had to do was balance the equation. So we have 2 moles of hydrochloric acid reacting with 1 mole of sodium thiosulfate to give us 2 moles of sodium chloride plus 1 mole of sulfur dioxide plus 1 mole of sulfur and plus 1 mole of water. Okay, and that's that. It says now describe a test and state the observation that can be used to confirm the presence of the sulfur dioxide gas produced from the reaction. The test would be to use acidified potassium permanganate solution, and the observation will be such that the purple solution goes from purple to colorless. Okay, and that's because of the manganese transition metal, which starts with a +7 state, as you can see there, and it's reduced to a +2 state to give it that colorless solution. And then of course they brought moles for you to calculate. It wasn't too bad. Determine the mass of sulfur dioxide produced when 50 cubic centimeters of the gas is collected at standard temperature and pressure. So they give us the relative atomic masses for sulfur, oxygen, and they give us the relative atomic masses for sulfur and oxygen, and they tell us how much space 1 mole of gas occupies at S/P, which is 22,400 cubic centimeters. So I equated 1 mole, because it's of any gas, so 1 mole of the sulfur dioxide would occupy this amount of space here. So you want to find out how many moles of sulfur dioxide would occupy 50 cubic centimeters. And then we do a nice switcheroo. Since we want to find x, we put x up here, we bring this down and we carry this across. So it's just like a cross multiplication, a transposition if you may. We get 0.002083333 moles of sulfur dioxide. So I write out everything so that at the end, when I round up, I can get the correct number. So if 1 mole of sulfur dioxide has a mass of 64 grams, I'll show you the working here, because sulfur has a mass of 32, and then we have 2 oxygen atoms, which have a mass of 16 grams. And so we add all of that up and get 64. So if 1 mole has a mass of 64, then this amount of moles will have less mass. And so we multiply that 64 by 0.00208, multiple 3's going across there, and we get 0.13 grams of sulfur dioxide. So we're given a table to complete. It's table 1. It says record the temperature readings for each of the experiments shown in figure 1 on page 4. So you would have had to go over on page 1, which is page 1 here, and we record the temperatures here. So we see 13, 14, so the temperatures increase as you go upwards. So the first one is 14, and then the second one is 20.5. Then we have 27, 33, 35.5. And how do we know that? We have 1, 2, 3, 4 spaces, so we're going up in twos. So this would be 2, 20.2, 20.4, 20.6. So this is halfway in between there. So 20.4, 20.6, so that's halfway, 20.5. Okay, so that's how you do it. Each point is a 0.2. Okay, and then they tell us to work out the rate of reaction, and they tell us calculate to 3 decimal places the rate of reaction for each experiment, given that the rate is calculated as 1 divided by the time. So they have the time here, and so we divide 1 by the time given. It said record the results in column 4 of table 1. So you need to follow the rules. You have to have 3 decimal places, which I don't. I actually have 3 significant figures, so that was a little mistake. So this should be 0.025, 0.042, 0.067, 0.091, and then 0.100. So 3 decimal places. So let me correct that. So I would have here, we'll cross out this, and then I'll cross this out because we just want this value, and then I'll cross this out because we just want this value, and again we're crossing this out, and then we have here, this is fine. So we have 3 decimal places, so that was my mistake. I said 3 decimal places and not 3 significant figures. So let's hope that everyone did not make that silly mistake. Okay, so obviously I would have used these points, but that's okay. You should get a similar value because they're not that far off. For instance, 0 shouldn't affect the 0.025. The 0.417, it shouldn't affect it that much because that's very close to 0.042. So a polymer graph using those numbers, and I would have gotten this beautiful curve right here. And the nice thing about chemistry exams nowadays, they give you the scale already calibrated, which is nice. Okay, so you just have to figure out what each little space in here would be, which would be for down here, every two little spaces we want, and for here it'll be 0.001. Yeah, okay, so that's how that would work here, 0.001 as you go up. And so I got this nice curve, and so what I did, I made my points. Everybody should have gotten a curve like this on their exam. I made my points in pen, and then I drew my curve in pencil so that I could rub out until I got the perfect curve. Well, until the curve was perfect enough for me. And then, so that would have given you how many points? In all, you would have gotten 15 points for following instructions. So it says here, using the axes provided in figure 2 on page 7, plot a graph of rate of reaction versus temperature for experiments 1 to 7. Draw a smooth curve to the points. So you're getting your marks for the points you plot. All right, yes. So we now says, the question says, using the graph you plotted on page 7, Explain how the change in temperature affects the rate of the reaction between sodium thiosulfate and hydrochloric acid. Well, if you look at the graph, you see it's increasing. So you would say the rate of reaction between sodium thiosulfate and hydrochloric acid increases with increasing temperature. Okay, so now we're on question 2. It says, the most stable form of the element oxygen has a mass number of 16 and an atomic number of 8. It can also exist as a radioactive isotope. Define the following terms. Atomic number. The atomic number indicates the amount of protons in the nucleus of the atom. It also indicates the amount of electrons in the neutral atom, as well as it indicates the atom's position. So you didn't have to write all of that. You could just write the first sentence and you're doing good. It's only 1 mark. So what is the mass number? The mass number indicates the number of protons and neutrons in the nucleus of the atom. And then isotopes. What's an isotope? Isotopes are the same type of element that have the same number of protons but different number of neutrons, hence their mass numbers are different. For example, isotopes of carbon are carbon 14, carbon 13, and carbon 12. And we must state that these elements, these atoms are unstable. So if you put in that isotopes are unstable, they're usually unstable, that will give you a mark as well. Then it says use a dot and cross diagram to show the bonding present in oxygen gas. So I did the Lewis dot structure. You could have done this as well. And I use only the valence electrons. So this shows that you have 2 bonding pairs in here, which means that the bond between, there's a double bond between the 2 oxygen atoms. And then we have 2 lone pairs each on each of the oxygen atoms. So in all you have 4 lone pairs. So you could have done it like this or like this. Then they said there are many uses of radioactive isotopes in everyday life. List any 3 uses of radioisotopes. And so I listed at least 4. I said cobalt-60 is used to kill cancer tumors in radiotherapy, and then we have uranium-235 is used as an alternative source of energy to fuel nations. Carbon-14 is used in carbon dating to determine the age of fossils. Then we have americium-241 is used in smoke. Then we have here says carbon burns completely in excess oxygen to produce carbon dioxide. Write a balanced chemical equation including state symbols to show this reaction. So I have the carbon as a solid plus the oxygen as a gas to give carbon dioxide, and it's balanced. And then they said carbon burns in limited oxygen supply to produce carbon monoxide. Write a balanced chemical equation including state symbols to show this reaction. So we have carbon monoxide, which is CO. Carbon monoxide, monoxide means 1 oxygen, and it's balanced as well. So we have 2 carbon atoms on both sides, and we have 2 oxygen atoms on both sides. So it's balanced. So it says compounds A and B are straight chain hydrocarbons whose molecular formulas are C5H12 and C6H14 respectively. State 1 natural source of hydrocarbons. Crude oil, or another word for crude oil will be petroleum. Then it says state 2 uses of compound B. So if you didn't know, you could always stick with your safe words for these questions, where you could say it could be used as a starting material for plastics, and it can be used as a source of fuel. So that would have gotten you there. But I wrote specific answers. I said compound B can be used to make glues for shoes, leather products, and roofing. Hexane can also be used as fuel, as a minor component of gasoline, and can be blended with diesel. Hexane can also be used to make plastics and synthetic rubber. Okay. And then the axe, this is an easy one. This is a draw the fully displayed structure of compound A. And compound A would be C5H12. So just make sure you have 5 carbon atoms bonded to 12 hydrogens, and make sure each carbon has 4 bonds. They said draw the fully displayed structure of compound B. I remember compound B was C6H14. Then the next question asks, list any 4 general characteristics of a homologous series. They usually used to ask for 3, and now they have 4, which was a way to mess with you. So the main ones would be to say they have the same general formula, they have the same chemical reactions, same functional group, common method of preparation. That's the 4th one. Deduce the homologous series to which compounds A and B belong, and because they have all single bonds between them, they belong to the homologous series of alkanes. I think the organic chemistry questions are some of the nicest ones. I don't know. How do you feel? All right, so for this one, they said compound B, C6H14, burns completely in oxygen to produce carbon dioxide and water, which is what always happens when they combust. So it says write a balanced equation including state symbols for this reaction. So because what I always tell people, when you're balancing hydrocarbon equations, combustions, you always want to balance the carbons and the hydrogens first. So what I did, I wrote down the working for you. You want to balance the hydrogens and the carbons first, and if you end up with an odd number, okay, what you're going to do is take that odd number of oxygens and put it over 2. Like I have here, I have the list here. It says balance the carbons and hydrogens first, then balance the oxygens, and if there's an odd number of oxygens, place the number over 2, then multiply the entire equation by 2 to get rid of this denominator here. And so every entity will be multiplied by 2, all right, across the board. And you end up with this answer here, which is 2 hexanes plus 19 oxygen molecules to give us 12 carbon dioxide molecules plus 14 water molecules. And you see here that everything balances after you do that little work. So now we're going back to inorganic chemistry, and it says magnesium and lead are metals often found in living things and in the environment. Explain metallic bonding in metals. Well, metallic bonding is the electrostatic attraction between positive metal ions and delocalized electrons. It says give the reason why metals conduct electricity in solid form. Metals contain delocalized electrons. These mobile electrons enable the free movement of electric charge through the metal. Owing to this, metals have a very low resistance to current. It says now state any 2 harmful effects of lead and its components on living things and their environment. So lead can cause damage to the brain and the nervous system. It can also cause slowed growth, hearing problems, and headaches. Other problems associated with lead are anemia, hypertension, renal impairment, that's something to do with your kidneys, immunotoxicity, and toxicity to the reproductive organs. So it can really make you sick ingesting lead. That's why they got rid of lead pipes and lead paint and anything lead. A chemistry student conducted a series of experiments using an electrolytic cell to test the conductivity of magnesium chloride. The materials used to set up the apparatus and the students' observations were recorded in table 2 below. So we have all of this. And it tells us when the bulb lit up and when it did not. And the questions ask us why. It says, explain why the bulb did not light up in experiments 1 and 3. Well, in experiment 1, PVC plastic is an insulator, hence it has a high resistance to electric charges passing through it. PVC plastic does not conduct electricity, and it doesn't contain any mobile electrons. Yeah? In experiment 3, solid magnesium chloride does not contain any mobile electrons, hence it has a high resistance to current passing through it. All of the ions in magnesium chloride, and there should be a 2 right here, are strongly bonded to each other via ionic bonds. So all of the ions are involved in bonding, hence there are no mobile electrons or ions inside of that magnesium chloride lattice. Then it says, explain why the bulb lit in experiment 2. Well, graphite and the aqueous magnesium chloride contain mobile electrons and ions respectively. This means that they have a very low resistance to current, which allows current to pass through them easily. The electrons are able to pass through the graphite and the aqueous solution of magnesium chloride to provide energy to the light bulb so that it can produce light energy. I must have been really tired. Okay, so state the process that took place in experiment 2. If you wrote electrolysis, you are correct. Magnesium readily reacts with oxygen in the air. Write a balanced chemical equation for this reaction. And we have magnesium as a solid and oxygen. And once you burn this, you're going to get a white solid forming. But the reaction is brilliant. You have a bright white light that is given off. It looks just like fireworks. Okay, so that's the balanced equation. We have 2 magnesiums here, 2 magnesiums here, 2 oxygens here, and 2 oxygens here. Great. Question 5. Proteins and starch are examples of natural polymers which are formed through the process of condensation polymerization. Define the term polymer. A polymer is composed of very large molecules called macromolecules, which are multiples of simpler chemical units called monomers. These can be natural or synthetic. It says, define the term condensation polymerization. This is where water or other small molecules like hydrogen chloride and ammonia are produced during condensation polymerization. The manufacture of ethanol makes use of the fermentation process. Define the term fermentation. Well, I have 2 definitions. It says, fermentation is a metabolic process that consumes sugar in the absence of oxygen. I also wrote that it is the process in which a substance breaks down into a simpler substance without the presence of air. Microorganisms like yeast and bacteria usually play a role in the fermentation process, creating beer, wine, bread, yogurt, and other foods. Write a balanced chemical equation including state symbols to show the process of fermentation. So you would start off with glucose, and from there you put the yeast in there, which is the catalyst. The zymase in the yeast causes the glucose to break down to ethanol, 2 moles of it, and 2 moles of carbon dioxide. Draw the fully displayed structure of ethanol. So we know ethanol has 2 carbon atoms. This is fully displayed, so they want to see all the bonds. Sometimes you could join up the OH. I don't think they're penalized for that, but they want to see the bonds, And that's how you draw ethanol. During a demonstration of the winemaking process in the school's food laboratory, a technician separated a pure sample of ethanol. However, the flask was not labeled and the water was accidentally poured into the sample. Using a line diagram, draw and label the apparatus that could be set up in the chemistry laboratory to obtain the pure ethanol from the contaminated sample. So we have here a fractionating column. We have a warm bottom flask with the alcohol and water mixture. The thermometer here. This is a condenser, and then we have cold water going in at one point and coming out at the other point, so you can condense the gas that's coming off first, which would be the alcohol. So you condense alcohol, the gaseous alcohol, back into liquid form, and we'll get the alcohol coming off first. I have water for some reason, but the alcohol will have a low boiling point, so the alcohol will come off first if you have it boiling at least 78, and then when you see the drips stop coming off, then you could take off this and put on a new receiving flask, and you could increase the temperature here to 100 degrees Celsius, and then pure water will come off at that temperature, because that's the boiling point of water. Okay. All right. And the sixth and final question. Here we go. Alka-Seltzer and Epsom salts are common remedies used in the Caribbean. Alka-Seltzer is an acid used to treat upset stomach, and Epsom salt is used to treat sprains and muscle pain. The active ingredient in Alka-Seltzer is sodium bicarbonate, and in Epsom salt is magnesium sulfate. So to tell you exactly what these things are, they say water is called a universal solvent because it dissolves many substances. Epsom salt and Alka-Seltzer work by dissolving in water. Explain why water is a good solvent. The water molecule is polar, and it has the ability to form hydrogen bonds with other polar mixtures and substances. The hydrogen atoms have a positive electrical charge, and the oxygen atom has a negative charge. State two properties of water other than it is a good solvent. So I put a bunch. I said it is polar, it has a high specific heat capacity, it is less dense as a solid than as a liquid, and it has a high heat of vaporization. State any two other compounds that dissolve in water. So we know salt, like table salt, sodium chloride, dissolves in water, and we know glucose, sugar, also dissolves in water. Question 6 always tends to give us headaches because they try to go out of the box. And you know what's funny? The study guide didn't even have anything to do about hard water. I know what books has. The book that has in this information is the Muhammad and Muhammad. It's a really good book. I had it as a kid, and that was a while back. All right. So continuous use of Epsom salt in water may cause hardness of water that does not happen with Alka-Seltzer. State the type of water hardness caused by dissolving Epsom salt in water. Well, it's called permanent hardness. Explain why Epsom salt causes hardness of water. Well, Epsom salt is magnesium sulfate. Due to water's excellent solvent properties and its polarity, magnesium sulfate, which is a polar substance, is able to easily dissolve in water. Sulfate salts contribute to the hardening of water. They make water permanently hard. Permanent hardness cannot be removed by boiling. When hard water and soap are mixed, the magnesium ions react with the soap molecules and form a solid material called a precipitate, which does not dissolve. It destroys the soap. Explain why boiling the water will not remove the hardness caused by Epsom salt. Well, magnesium sulfate does not precipitate out of water as its temperature increases due to it being boiled. So as the temperature increases, magnesium sulfate doesn't precipitate out, it makes it harder. Permanent hardness is caused by dissolved magnesium sulfate, which does not decompose or break down when heated. Hence, it cannot be removed by boiling. So all of these are reasons why you can boil magnesium sulfate out of water. Alright, so identify 2 salts that cause hardness of water and can be removed boiling. So all the carbonates can be removed by boiling, like magnesium carbonate. Anything carbonate can be removed by boiling, and calcium carbonate. When used as an antacid, Alka-Seltzer neutralizes the hydrochloric acid in the stomach. Write a balanced chemical equation including state symbols to illustrate this process. So we know the sodium hydrogen carbonate solid, because that's the Alka-Seltzer, remember? And you know how Alka-Seltzer tablets look, they're white, they're solid. Then we have the hydrochloric acid, which is aqueous. And from that we know when we react an acid with a base, and it's a hydrogen carbonate, you're gonna get the salt, the carbon dioxide gas, and water. So our salt will be sodium chloride, which will be aqueous, and then we have the gas coming out. So you're gonna see some effervescence, which is the bubbles, and then you have water. That water will be what the sodium chloride is dissolved in, right? And here endeth the scripture reading on paper 2024 for chemistry. I hope everyone was able to answer at least 4 of the questions fully, even 5. Difficulty for this test on a scale of 1 to 10, I give it, let's say, a 3. It wasn't difficult at all. You just had to know your stuff. They didn't have lots of moles on it. So I give it a 3. It was not difficult at all. I really enjoyed answering this question. As you can see, I was able to go through it in 34 minutes. Usually these tests take at least 40 minutes for me to do, or even 50 for me to go through. So best wishes. Always choose the Science Hub for your everyday needs in chemistry, physics, and math. See you around.